Pretty obvious, right? Well, maybe not. Because the answer is actually false. Believe it or not, they are exactly the same color. And if you want to know why, you'll have to stick around. This is a show about perception and your brain. For the next hour, we're going to mess with your senses. We're going to put you through a series of tests. And if you play along, you'll see things that aren't really there.
Oh my God, no way!
Hear strange sounds that baffle your brain.
Ba, ba.
And feel unique sensations that are difficult to describe with words. So listen up and watch closely. This is your brain, isolated from the world, inside your skull. Your senses provide its only clues to what's going on out there. But how can your brain take the limited information from your senses to build you a trustworthy reality? If you stick around for the next hour, we're going to show you, with a series of illusions you can't help but fall for, even after you're in on the gag.
Oh my God.
So, are you ready? Let's go back to the gray boxes. Still don't believe these two squares are the same shade of gray? This man, experimental neuroscientist Bo Lotto, is going to show you why your brain is constantly being fooled by what it sees.
What illusions tell us is that what we're trying to see is not the world as it is, but something else. We're actually generating perceptions of a world that's useful to see. And that useful perception doesn't actually have to correspond with what's actually there. Okay, come on over. We're going to do a test.
Bo's going to prove to you and a group of volunteers that the two squares are the same color gray.
When you open your eyes, right, first time in the morning, say, do you think you see the world as it really is?
I say yes.
Yeah, you're seeing it. Oh, you're
Seeing and
definitely.
believing.
That depends if I'm wearing my glasses or not. Yes.
Yes. Yes? Yeah?
I think so.
I mean, why not? All right, well, look at this cube here. What if I told you that those two surfaces are exactly the same? Would you believe me?
I wouldn't.
Okay, come on up. Okay?
Bo has attached a gray swatch to one of the surfaces to allow you and the volunteers to test this one out for yourselves.
Take that dot and move that nice up here, right there.
Oh my God. No way. I want to do it again.
That's crazy.
It's mind-boggling. Your mind's been blown.
Are you also having trouble believing this one? Well, take a look at the illusion again. If you want, try holding up one of your hands and block this section of the image. If you're having trouble seeing it, we'll help you out. Crazy, right?
Different? Same.
It's freaking me out.
What's going on?
Tell us.
Are we changing the surface? What's
No.
changing?
Our perception.
Our perception's changing.
Yeah.
Okay, why? That's the question. If we could understand this, we would understand how the brain works.
Are you wondering why this happens? How two distinctly different shades of gray could actually be the same color? In this case, it has to do with how your brain uses shadows to make decisions about what it's seeing. Take a look at this object. One glance and you know what it is. But how do you know what it is and where it's positioned in space? Well, let's break it down. The light reflected by this object is converted by your eyes into an electrical signal and is sent down a neurological pathway called the optic nerve to the back of your brain. Starting in this region, called the visual cortex, the image is cross-referenced with memory of past experiences stored throughout your brain as you try to identify the object. Once it's figured out what it is, your brain has to decide how the object is positioned in space, and one of its most reliable tools is to use shadows. Here's another illusion to show you how that works. Take a look at that basketball again. We're going to put it on the court and move it along a diagonal. Now we're going to add a shadow. It's still moving in the same way, right? Okay, so what if we change the position of the shadow? Do you think we can trick your brain into seeing the ball's motion differently? Does it look like the ball is taking off now? Let's tweak the shadow one more time. What's the ball doing now? Looks like it's bouncing, right? In a world with a single light source, your brain has learned to trust shadows as a near foolproof way to know the behavior of objects in space. And in general, it's worked. Until now.
Your brain's using its past experience to generate its perceptions of the world. And so the brain looks at this image and it says, this surface is in shadow, okay? If this surface were actually in shadow and returning the same amount of light to your eye as this surface, which seems to be in light, this would actually have to be more reflective. There's less light hitting it, but the same amount is hitting your eye as this one, right? And so that's why you see it as lighter.
Was that confusing? Let's simplify this. Bo is saying the gradients and shadows he's painted here give your brain clues that the top is a well-lit gray surface and the bottom is a poorly lit white surface. Clues your brain trusts because of your past experience with shadows. But, as you're beginning to see, shadows can lie to you, and do all the time.
Behind me, there are two shadows that both appear gray because we have two white lights that are facing me. Now, if we replace with a purple filter, let's see what happens to the colors you see. The shadow no longer looks gray, it looks green. So the question is, where is that green light coming from? Well, there is no green light. The shadow's gray, but it looks green. Why? Because of the color that's surrounding it. Context is everything.
This illusion uses shadow to show you that another one of your most trustworthy sources of information about the world can be faulty. Color.
Light is something that exists in the world. It's a physical thing. And our perceptions and vision begins with light. But color does not exist in the physical world. Color is completely a construct of our brain. In fact, all our perceptions are constructs of the brain. Nothing that we see is, in fact, out there in the world. It seems completely counterintuitive, but color really makes that point.
Not buying that color is all in your head, too? Well, take a look at Bo's next illusion.
We made this cube to show you that illusions are no different from our everyday perceptions. These two surfaces here look very different. The tile on the top looks very dark brown. The one on the side looks a bright orange.
So, what do you think? Are the two squares the same or vastly different colors?
This surface is exactly the same as that surface. And I can prove that to you by taking this tile off and putting it at the top. Now you can see that they're physically the same. If I put it back down into the region which appears to be in shadow, it now again appears bright orange. Why? What you might be amazed to learn is that this whole cube is an illusion. There is no shadow here. This surface is consistent with your past experience of shadow. So your brain interprets this surface as if it is in shadow, which it isn't. But you can't help but see it that way.
You don't realize it, but color is something that your brain is imposing on the world. A feature of light that has proved useful to separate the beach from the water, or the bear from the trees. Scientists like Lotto have learned how to hack your brain's expectations to show that color, like shadow, is just a convenient shortcut your brain uses to identify objects and make sense of their behavior in the world.
Okay, what about this one over here? We have two cubes. One that looks like it's in blue light, one that looks like it's in yellow light. Okay, and I want you to see these yellow tiles on the left, and we have blue tiles on the right. All right, everyone see that? Okay. Now, what would you think if I told you they were all the same?
Oh, that's crazy.
Yeah? Crazy. Yeah? These yellow ones on the left are all physically the same as the blue ones on the right. So, why don't you come up,
Okay.
yeah? And take this tile here. Looks yellow to you there, yeah? grab that corner and put it up there.
This corner?
Yeah.
Up here?
Yeah. What color is it now? Does anyone see that? What color is that?
Gray.
It's gray. What about this one?
It's gray.
Our eyes are cheating on us.
So what's going on?
The environment and the surroundings.
Yes, it has everything to do with the context, the surround. But what's happening is that surround is changing the meaning of these tiles, and it's the meaning that you're seeing. So you don't see the tiles, you see their meaning based on the context.
So, if shadow and color are imperfect indicators of what's happening out there, what other tools does your brain have to figure out what's going on in the world? Let's take a look. Here's an easy question. Which of these two balls is larger? The soccer ball, right? Nope. The golf ball is actually much bigger. Did this illusion stump you? How is the golf ball actually bigger? Let's fill in the blanks. If this seems like a cheap shot, it is. We didn't give your brain the information it needed to solve the problem. You had shadow and color, but only after adding some perspective lines did it become clear what was going on. Baz Rokers is a scientist at the University of Wisconsin-Madison who studies how your brain uses depth and perspective cues to make sense of the world around you.
We have two eyes, and the information through the two eyes gets processed by the brain and somehow gives us a sense of our visual world. It tells us how far things are away from us and how quickly they're moving at us.
Rokers has special access to a Los Angeles rail yard to show you how your brain uses the 2D information it gets from your eyes to make a 3D reality.
There's a lot of cues that are informative to depth, and what the brain does is it tries to put those together. Lines that are parallel due to perspective are eventually going to be meeting together at the horizon, so at the vanishing point.
Just as it did with the gray boxes or the Rubik's Cube illusions, your brain relies on past experiences to decide how objects in this scene are positioned. Take a second to look around the room you're sitting in. Look for the lines that mark walls meeting the ceiling, or the edges of doorways and windows. Now, look back here.